Alright, welcome to section 8.3, equations that lead to quadratic methods. So basically, the main concept here is that we start with an equation. So once again, what is the definition of an equation? Well, pretty much you're given an equal sign and you have two objects that were set equal to each other. So this is not an expression, remember that? So we're given an equation and it's not initially quadratic, so it doesn't actually look like a quadratic in the beginning. And remember, quadratics are x squared. So it's not initially a quadratic, doesn't look like it in the beginning, but when you work with it, you'll find out that you can treat it like a quadratic and you can solve it using quadratic methods. So those are the kind of equations we're looking at this time. So let's take a look at the first one. So what do we have here? We have two fractions equal to 1. Well, as usual, I don't like working with fractions, and because this is an equation, I can go ahead and I'll find the lowest common denominator and use that to get rid of the fractions. So the lowest common denominator is x plus 2. So let's go ahead and multiply both sides by the x and the x plus 2. Oops, let me fix that. There we go. Okay. Okay, so we have both sides times x plus 2, x plus 2. And when I distribute that out, what do we have? We have 2 over x times x plus 2 plus 3 over x plus 2 times the x plus 2, and then that's all equal to 1 times the x plus 2. Okay, so the x's will cancel there, x plus 2's cancel there, and nothing cancels on the other side. So when I multiply this out, I get 2x plus 4 plus 3x equals x squared plus 2x. Once again, I did some of that distribution right there and right there. Okay, so does this look quadratic now? And it does because we have the x squared. So let's treat it like a quadratic and get the terms all on one side. I'll combine these two like terms here. That'll be 5x, so let me go ahead and write that out. 5x plus 4 equals x squared plus 2x. Subtracting 5x from both sides, and then subtracting the 4 as well. Once again, you do the opposite sign when you're getting rid of it. Okay, so now it's perfectly quadratic. Let's go ahead and see if we can factor this using the zero factor method. If that doesn't work, we might have to use a quadratic formula. So I believe we can factor it. It looks like x minus 4x plus 1 will factor, and that will give me the right answer. Yep. So once again, we set each factor to 0 now to solve. And one thing to note that's important. This step where you show the factors and set it equal to 0 is an important step that I do grade for. So just be aware for that and watch out for that. Okay, so adding, let's add 4 to both sides. And we get x equals 4. And then subtract 1 from both sides, and we get x equals negative 1. Now we have to be careful though. This was not originally quadratic. It was fractions. So am I not allowed to let one of these answers work? Well, if we check 4 and negative 1, 2 over 4 works out. That's not 0. 2 over 4 plus 2 works out because that's not 0. And then when we plug in the negative 1, we get 2 over negative 1. That's fine, no 0 in the denominator. And 3 over negative 1 plus 2 is also fine. None of these ended up with 0 in the denominator, so we're good. Both the answers work. Alright, let's go ahead and keep solving. Solve the following, be sure to check your solution. That's another thing to note. If it was not initially quadratic and you end up getting something that looks quadratic, you have to be careful because sometimes in the beginning, there's some symbol or some sort of operation that you need to worry about. So for the first problem, or the first equation we looked at, there were variables in the denominator. And we know we cannot let that have a 0. Now for the one we're looking at here, we have a square root, and we know we cannot have negatives in the square root, unless we're told that we're solving over complex numbers, which we're not. Alrighty, so to solve, let's go ahead and square both sides. And what do we end up with? We end up with x squared equals, well, that cancels out there, so I'm just left with 9x minus 20. And what do you know? This is a quadratic equation. So let's go ahead and set it to 0 and see if I can use the quadratic property. So I'm going to go ahead, minus the x squared from both sides, so we get negative x squared plus 9x minus 20. Now, I don't like factoring when I have a negative in front of my x squared, so let's go ahead and divide everything by negative 1, or you could multiply by negative 1. Both of them work. Once again, remember, if you're going to divide one item by a number, you have to divide every other item by that number. Just waiting on my pen. Okay. You got to divide every other number by the same exact item you're dividing. You can't pick and choose. Okay, so once again, think about treating everything fairly. You have to divide everyone by the same number. Then we get 0 equals x squared minus 9x plus 20. Can we factor this? Well, I'm looking for two factors that of 20. Two factors of 20 that when I add them, I get negative 9. So I know they should both be negatives. Well, factors of 20, 4 and 5, when I add them, I get 9. So that'll work, 4 and 5. And then the next step, let's go ahead and set them equal to 0. And solving. So add 4 to both sides. And I get x equals 4. And the next one. Add 5 to both sides. Once again, solving for x, and x equals 5. Are we done? Not really, because this was not originally a quadratic. This is a square root problem. So I need to check my answers to make sure they both end up making sense. So let's go ahead and check both sides. We're going to check 4 first. So does 4 equal the square root of, once again I put that question mark when I'm checking. Does 4 equal the square root of 9 times 4 minus 20? Once again, 4 is the item we're inputting to test. That's one of my answers. Then we have 4. Is that equal to the square root of? And 9 times 4 is 36 minus 20. That's 4 equal to the square root of 16. And yes, 4 is equal to 4. The square root of 16 is 4. So that one checks out. Let's check 5. So we're going to go ahead and check 5. We're going to plug in 5 into our original equation. And to see if it makes sense. So plugging in 5. Handwriting's getting a little too messy. Question mark, is that so? So we have 5. Is that equal to the square root of, that should be 45 minus 20. So is 5 equal to, well, 45 minus 20 is 25. And the square root of 25 is 5. So 5 is equal to 5. So both of these do check out. Awesome. Alright, so once again, you may not be told whether or not you need to check your solution, but on all of these you do, because in the beginning of each equation, we know by looking at it there might be problem numbers. Once again, fractions, you might get a problem number. You don't want 0 in the denominator. And radicals, you might have a problem number. We don't want negatives in them. So that's something that you should be able to identify when you're doing the exams. So now we have one of the weird case problems. What do you notice about this that looks weird, first off? Well, what I notice are these fractional exponents in an equation. We haven't worked with that yet. So this is a very special case. We call these ones these are perfect for something called U substitution. And what makes me think about this is whenever I see those fractional exponents in an equation, I think of U substitution. It doesn't always work, but it's a good idea. How do I know if it works? Well, the plan is, I pick the lowest exponent, and I set that equal to U. Which one of these is the lowest? Well, the lowest one is x to the half power. So let's set that equal to U. So I'm going to say let U equal x to the half. And one thing to notice, I put this off on the side. It's not inside my solving. Well, if U equals a half, and we're trying to work with quadratic equations, what would I get if I squared U? Well, U squared would equal x to the, well, multiplying that out, 2/3 power. So when I substitute this into my equation, this is 4 times, well, what was 2/3 power? that is supposed to equal u squared. So I'll sub that out. So it's 4u squared equals 3 times x to the half, or sorry, the third, which is supposed to equal u. So 3u plus 1. Now, does this look quadratic? It does. Even though it's not x, we still have that variable squared. So now this is in quadratic form. So let's go ahead and solve this like a quadratic. I'll subtract that to both sides. So negative 4u squared plus 3u plus 1. Once again, I don't like working with negatives. So I'll go ahead and divide out by negative 1. Can we factor this? Well, let's see. Factors of 4. Let's see. So we want to have a negative, so we know we're going to do a negative and a positive, because this last one here is a negative. And we want to end up subtracting to get a negative 3. So factors of 4 are 1 and 4, and 2 and 2. Factors of 1 are just 1. Now we can subtract any of these to get 3. We can subtract 4 and 1. Alright, so let's go ahead and do that. And we'll do 4u plus 1 and 4u, just u minus 1. Checking that out, we would get the negative 4u there and the positive 1u, which would give me the 3u. Awesome. Okay, well, let's go ahead and set these equal to 0 and solve. 4u plus 1 equals 0. U minus 1 equals 0. Minus 1 minus 1. I get 4u equals negative 1. Dividing both sides by 4. And I get u equals negative 1 over 4. Next side. Add 1 to both sides, and I get u equals 1. So can I box my answer? Am I done? No, we have to be careful. What's wrong? Well, we're told to solve for x. But we have just solved for u. How do I fix this? Well, don't worry. Remember, we know that u equals x to the 1/3. So let's go ahead and resub for x. So we know that x is 1/3, or sorry, u equals x to the 1/3. So swap those back out now that we've cleaned things up a bit. Ooh, how do I solve for x? Well, to get rid of a third, we're going to go ahead and raise both powers to the 3rd power, and that'll cancel out those. So I'm left with x equals 1/4 to the 3rd power. Distributing that 3, we get x equals negative 1 over 4 to the 3rd power, which is 64. And on the other side, once again, we still have to raise both sides to the 3rd power to get rid of that x to the 1/3. And we get x equals 1 to the 3rd power, which is just 1. So checking our answers. How would we do that? What is the danger we have in the original equation? Well, there really is no initial danger. Why? Because anything can be raised to the 3rd power. How do we know that? Well, remember, the 3rd power is just the cube root of x. And you can have positive or negative numbers inside there. So we actually don't have to check our answer. Alright, so why do we use u substitution? Well, it just helps to clean up our problem and make it look a little less, kapakahi, a little less crazy. Because those weird sort of fractional exponents, they can be kind of hard to work with. So if you can get rid of these and rewrite it in some nice form that you do know how to solve, like this, we know how to factor that and solve, then it's easier to work with. So that's why u substitution is used. It just helps simplify the problem for you. Okay, so let's take a look at the next problem. Example 4, solve the following. So what do we see here? Well, we have 5 times x plus 3 to the 2nd power plus 9 times x plus 3 equals 2. You know what? I've just noticed that both of the items inside the parentheses are the exact same thing. It's just one of them is squared. Which was a lot like what happened previously. these guys are basically the same thing. One of them was just the square of the other. So let's go ahead and see if U substitution would work. Can I substitute something in and make it look quadratic? Well, let's go ahead and let's try U sub. So I'm going to go ahead and say let U equal, once again we pick the lowest power 1, which would be x plus 3, which means that U squared would be, x plus 3 squared. So let's go ahead, swap out x plus 3 squared with U squared, and x plus 3 with U. And I have 5U squared plus 9U equals 2. And what do you know? That is a beautiful little quadratic equation, which we know how to solve. Thank you, U sub. All right, let's go ahead, set it to 0, see if we can factor it. Okay, so trying to factor. We know we're going to end up with different signs because that's a minus, so we need a plus and a minus. And we want factors of 2 and 5, that when we subtract them, we get a positive 9. So let's take a look at factors of 5. Just 1 and 5. And then factors of 2 are just 1 and 2. So let's go ahead and combine them. See if we can get 9. Well, I'm pretty positive 5 times 2, that's going to be the 10. And 1 times 1 is 1. So if I have a positive 1 and the negative 10, that'll give me the negative 9. So if I plug in the 5u here, remember when I'm thinking about FOIL, the 5 gets multiplied to the 2, so the 2 should be on that end. And then the 1s will go inside there. So that's going to be 1u. Alright, so we have it factored. Once again, if you need any help with factoring, please send me an email. I can give you some more resources on factoring. Alright, so those are factored. Let's go ahead and set each factor to 0 to solve. I get 5u equals negative 1. And let's go ahead and divide both sides by 5. And we get u equals negative 1 over 5. And on the other one, oops, that's the wrong one. That should be u minus 2. Are we done? No, why not? Because we're asked to solve for x, and we've only found u. So what does x equal? Or sorry, what does u equal? U equals x plus 3. So let's go ahead and sub that back into the equation to get my final answer. So u is equal to x plus 3, u is equal to x plus 3. Let's solve the easier one first, since we don't have to work with fractions. And we get x equals negative 1. And on the other one, we're going to have to work with fractions. Let's go ahead and subtract 3 from both sides. We have x equals negative 1/5 minus 3. We'll put that over 1. We have to build up the denominators. Let's go ahead and multiply the top and bottom by 5 to create the common denominators of 5. We get x equals negative 1 over 5 minus 15 over 5. So x equals negative 16 over 5. Now, do I need to check my answer? Well, if I look at my equation in the beginning, what am I doing with my variable? I'm only squaring my variable. Is there anything wrong with squaring a positive number? No. Is there anything wrong with squaring a negative number? No. So I don't need to check my answer. There's no danger with my answer here. So once again, when do we use a u sub? Usually, if you see, let's say, some binomial where one is the square of the other, then it's a good idea to try to see if a u sub would work. Or, if you see an equation that has exponents that are fractions, and one is the square of the other, like we saw here. And if that's the case, then once again, it's a good idea to try u sub. Alright, though, that is it for this video. If you have any questions, once again, please send me an email or stop by my office hours. We are nearing the end of the semester, so it's a really great time to get a little more extra help if you feel that you're just struggling with a few items. Once again, send me an email or drop by my office hours.